In this question, I want to find two numbers whose sum is 14 and the sum of their squares is a minimum. So because the equation is not given to us, we'll start first of all by defining the variables. So I'll say that x is equal to one number, y is equal to the other number. So look for the equation that has an answer, like is 14, so it's two numbers whose sum is 14. That's my isolating equation. So x plus y equals 14. So I'm going to isolate for one of my variables. I'll get y by itself, x take away x. So I have that y is 14 minus x. For my substituting equation, look for the one that has the max or min. So that's this one here, and their sum of their squares is a minimum. So that means that x squared plus y squared is equal to a minimum. So I'm only allowed one variable, so go back up to my isolating equation, and instead of using y, I will use 14 minus x. So I need to do a little bit of work here to tidy it up. So since I have 14 minus x squared, I want you to write that out 2 times so you're less likely to make a mistake. And then we'll apply the distributive property and group like terms. So applying the distributive property, 14 times 14, 14 times negative x times 14, negative x times negative x, and then I just want to tidy up. So grouping like terms, x squared and x squared is 2x squared. Negative 14 and negative 14 is negative 28. X plus 196. So this is going to have a minimum. So what I want to do is complete the square. So looking at this equation, I am going to factor the a value just from my x terms. So 2x squared divided by 2 is x squared. Take away 28x divided by 2 is 14x. Leave myself some room and put the 196 on the outside. So what I want to do is go up to my grid, and I'm going to complete the square for x squared minus 14x. So the only way I can get x squared, I put it here, is if I have x times x. Then I take my negative 14x and I divide it into 2 equal pieces like this. So the only way I can get negative 7x is if this is minus 7 and this is minus 7. So just do a little check. X times x is x squared. Negative 7 times x is negative 7x. Negative 7 times x over here, so x times negative 7, negative 7x. So I've done that correctly. To complete the square, negative 7 times negative 7 is positive 49. So I know that 49 will complete the square. So down here I will add 49 and also subtract 49. Now, just to refresh your memory, 49 take away 49 is 0. I can add 0 to any equation without changing its value. So what I want to do is focus on my perfect square trinomial, which is on the inside here. That's the perfect square trinomial. From my grid, I know that factors as x minus 7 times x minus 7 or x minus 7 squared. So keep the 2 on the outside, and it's x minus 7 squared. Now I have that 49 that's on the inside there, so I have to do 2 times the negative 49 and bring it outside. So 2 times negative 49 is negative 98. So on the outside, I'm going to have a negative 98 with the positive 196 that's already outside. So combine those like terms, and I end up with 2 times x minus 7 squared plus 98. So what we're going to do is we're going to look at the vertex, and we're going to analyze that within the context of the question. So here's my completed square form. Let's state my vertex. My vertex is on the inside, minus 7 opposite. On the outside stays the same. When you have your vertex, this is what the max or min is. This is when the max or min occurs. Now, since it is a positive a value, positive means I open up, which means I in fact have a minimum, and that minimum is a minimum product. So I have a minimum product of 98. Now, when does that minimum product occur? Well, it occurs when x equals 7. Well, what was x? Let's go up here. X was one of the numbers, so one of the numbers was 7. Y was one of the other numbers, and y is 14 minus your x value, which is 7. 14 take away 7 is 7. So my other number is 7. So to answer this question, the two numbers are 7 and 7, and the minimum product is 98.